As part of the demo, so we are going to see what is the existing problem with traditional approach. Okay, and we'll see what is big data. What is big data? And we will see characteristics and classification of big data, and we will see 6V of big data. Okay, we'll see 6V of the big data. Then we are going with Hadoop architecture, right? So first we are going to see what is the problem. First we are going to see what is the problem, and we are going to see who is causing the problem. The problem is causing by big data, right? Then we are going to say solution. This is a
Just one
solution.
more thing.
Yeah.
Sir, this is here.
Tell me,
Just,
Joseph.
yeah, actually, the difference between big data and Hadoop, I'm not clear about what is the, the difference
Yeah,
in between
the,
those two.
the very good question. So once after finishing this demonstration, you will be answer for that. You will have the answer,
Okay.
and you are able to answer that. Okay, and this is the
Okay.
problem. This is the problem, and this is the causing the problem. I mean reason for the problem. Okay, reason for the above problem, cause of the problem, and this is solution. So it makes sense, right? So you know the what is the problem, and you know who is causing the problem, and you know what is the solution. It makes clear,
Yeah.
right? It gives a very clear picture, right?
Yeah.
Right. So let me start with the existing system. Okay, it's called a traditional approach. It's called traditional approach. The traditional approach is nothing but RDBMS, I can say RDBMS approach. Okay, why we are calling this a traditional approach? So okay, before that, let me tell you what is a tradition. What is a tradition?
Like uh,
Our
all that
ancestors,
are yeah.
our parents, someone already set some set of rules according to their time, in their time. So according to what are the problems they faced, and according to them they set some rules and regulations, or some those rules will be following till now, right? It can be anything. It can be our Indian tradition, it can be anything, it can be our family tradition, it can be anything, right? So our ancestors set up some rules based on their experiences, based on their what the problem they faced, based on their knowledge. They have set up some set of rules, and we are following the same rules as of now. That kind of approach we call as a traditional approach. Do you guys agree with me?
Yep.
Right? Let's look at the traditional approach. Then we will how we are processing the data. How we are processing the data in the traditional approach. First we'll look at that. Then we will move what is the problem in it. Then we will move who is causing the problem in it. Then we'll move to the solution. I hope this makes you very much clear. It makes you the strong in your basic knowledge. Okay, let's look at how the traditional approach is working. These are the sources. Sources means from where we are getting the data. These are the sources means from where we are getting the data. Like your financial institutes, dollar means financial institutes like a stock exchange, banks, or anything else, financial institutes. And your social media, your sensors are like any sensor. It can be your mobile sensors, it can be a car sensor, any sensors, it can be your laptop, it can be your any sensors. And it can be your CRM tools. Like what are the CRM, so Salesforce or any kind of CRM tools, or your ERP tools or satellite. There are different sources. Why we calling them as a sources? Because they are giving us the data. They are giving us or data. They are generating the data, right? What type of data they are generating? They are generating the raw data. What type of data it is? Raw data. Why we call this a raw data?
It is not in processed form. It will be
Exactly.
like
Exactly. It is data directly coming from source, right? It is not gone through any processed form. It is not gone through any processed. So it is directly coming from the sources. So that kind of data will call raw data. That raw data, how we will process? We'll use some ETL tools. What are they? Some ETL tools. What are the example for ETL tools? Informatica,
Informatica,
yeah,
BI.
BI, Talent. There are some tools, right? We will use ETL tool. What is ETL? E for extract. Extract the valuable information from the raw data, transfer them, and load into data warehouse system. What we will do? We will extract, transfer, and load into our data warehouse system. What is this? Data warehouse system. Before loading into data warehouse system, what we will do? We will apply the normalization. What is the normalization, guys? You guys are very good at the normalizations because you guys are from the same background.
Yeah, means reducing means avoiding this
redundancy and inconsistency generally we remove from the data.
Exactly.
From the tables.
Exactly. So removing the duplicate records, removing the redundant data from the processed data, right? So after applying the normalization, we will store into data warehouse system. After storing into data warehouse system, or after storing the data warehouse system, there will be some machines or some clients like your data scientist or your business analyst or someone who will query this data, to generate a reports, right?
Yeah. Yes.
For analysis.
Your business analysts, what are they? These are reports.
Yeah.
Your BA analyst, business analyst, or your data science people, data warehouse administrations, some XYZ people, right? So
Yes.
how this one was working? So these guys will have their dashboard here. The dashboard means their UI. Those guys will be having their dashboard here. They'll be selecting something there and they're expecting some graphs, right? So when they submit button here, the query will be formed at background. Let's assume that select query. And the query will go to data warehouse system, then it will process, right? That's the process. Okay, now look at here. I'll take one example and I will make you understand how the traditional approach is working. Let's assume that I have Amazon data with me. Let's assume the last 6 months Amazon data is there with me. Okay, what is this? Amazon data, like Amazon log file. Let's say it's Amazon log file. Now I have went here retail process, then I loaded into database. Let's say I have loaded into database. Now from this Amazon data, I want to understand how many new registrations are there. How many new registrations happened last 6 months? How many people have purchased home appliances? How many people have purchased electric goods? How many people purchase so clothes? So like that. Okay, I want to understand. I want to generate a report for it. So based on that, so I can get into a new market. Based on that, I'll get into a new market. I'll come with a new product. So what will happen? We will load this data. We'll load into tables here. We'll load the data into tables here. Then I will select a query. I will issue a query here, right? Let's assume that this data is close to 50 GB. Let's assume that. Okay, just let's sample example. The data warehouse has a 50 GB now. When I query this query required how much data it has to process? 50 GB, right? This query has to process 50 GB data, no?
Yes.
Now, when I issue the select query, the query will execute where?
Database.
No, in the client machine, from the client machine, right? When I issue the query from here, it will talk to a data warehouse system, then it will download the data, guys. to download the data to your client machine. I don't know whether you guys are aware of it or not. It will download the data from the data warehouse system to your client machine. Then your select query will apply on this in your client machine. The data will come down here, and the query will be applied on this, in this machine. So where the process will happen and which memory? Every computer will have a computer, mobile, anything. Every computer will have a memory, right? Two type of memories. What are they?
ROM and RAM.
RAM and ROM.
RAM and
ROM, right? So where the process will happen, guys?
RAM.
In RAM only. Either it's your mobile, it's your laptop, it's your desktop, it's your TV, whatever it is. So forget about it. Whatever the electronic device, what is a computing device, right? The process will happen where? In the RAM. It means that my client should capable enough to, my client machine, this machine, it's capable enough to hold 50 GB of RAM. It means I should have a better processor, better RAM of my client machine. Do you guys agree with me?
Yeah.
And for what I need a better processor, better RAM here? To generate the reports in a given time. I want the report in 10 seconds or 5 seconds. 5 seconds is the benchmark now. I want the reports in 5 seconds. So I should have a very good machine here, right? Let's assume that my data warehouse system is there in Singapore or in USA, wherever it is. I'll take USA. My data warehouse system, it's a data warehouse system is nothing but a data center, right? This is my data center is there in USA. My data center is there in USA. Now I'm querying from India. I'm querying from India. Now that data needs to be downloaded from USA to India machine, right? You may ask, Sir Ravi, even though it's USA or India, no matters. We both are in the same network. We both are in the same network, no matters. The speed will be more, right? But anyway, in this case, I need to download the data to my client machine, right? To download 50 GB data in this machine, let's take, it's a very high bandwidth. It is taken only 15 minutes to download. Let's assume that it will take more than that. I'm just giving an example, okay? And to process this data by applying this business logic, select star something. This business logic has to apply in the 50 GB data, right? So it has to process in this machine, right? How much time it will take? Let's assume that it has taken another 15 more minutes. So total how much time it is taken? 30 minutes. It is taken 30 minutes. But I need to report in how many seconds? Even if you take 10 seconds also, where is 30 minutes? Where is 10 seconds? Right? Now, this is how the data is getting processed traditional approach. Now you may say that, Ravi, this is well fit, right? It's working very perfectly, right? Why we need to go with Hadoop? Why we need to go with other things? It is working very good. I have a source here, I have a ETL here, I have a data warehouse system, I have a client machine. I can just, it's awesome. Its architecture is too good, right? Then when it is failing, when my data is more, when my data is grown, if you take in 80s and 90s, what was the data we are handling? Very less amount of data, not even 50 GB. Very less amount of the data, right? If you take 80s, it's only MBs. If you take 19s and 2000s, it's just a GBs, right? So the system is failing when data is increased. When data is increased. When data is increased. How it is failing? Ravi, tell me how it is failing. So when my data is increased, I need to invest on my ETL tools, right? ETL tools are not open source. Are you guys agree with me? You need to buy a license. You need to buy a license for 1 machine, 10 machines, 1 user, 10 users based on the data you are going to process. You need to buy your ETL tools. The very first point, cost, right? And the second thing, your data warehouse, so you have designed for the less amount of the data. The data is grown. When the data is grown, you need to replace the system, or you can use the same system. I need to buy
increase the size.
I need to buy a bigger machine, right?
Yeah.
There also I need to invest something, which is again a cost. Okay. Now see, when the data is increased here, I need to download the data and apply my logic, which is taking so much of time to process. The very important second point is time. Time is more precious than cost. As per my understanding, time is more precious than cost. Cost today we can earn some money, we can invest, but time we cannot, right? So why it is taking time? Let's see here. It has to download the data. It has to download the data. It means your data is moving. Moving data is too costly. Moving data is too costly. Today is 50 GB, tomorrow it's 100 GB. You have to move 100 GB data one place to another place. Moving data is costly than moving computation. Computation means your logic. Let's assume that I have given some query to you. You have written 100 lines or 200 lines of PLSQL or SQL code. What is the size of that file, Debashish? Let's assume that you have 200 lines of code. So what will be the size of the 200 lines of code?
That will be in KB.
KB or 1 MB?
1 MB. Let's take worst case 1 MB. Okay. So downloading 50 GB is better or uploading 1 MB is better? Uploading 1 MB, upload this 1 MB, apply this logic in the data warehouse system only and take the results.
Yeah.
Which is better? Uploading is better.
Uploading.
Right? This is called moving computation is better than moving data. What is that? Moving computation is better than moving computation is better than moving data, right? Moving data is costly, so which is taking so much of time. This is called moving computation towards the data. Moving computation towards the data is called data locality. What is that? It is called data locality. Data locality means very simple. If you are there in your hometown only, you are doing your work at your hometown only, will you be local to your hometown or you are non-local?
Local.
You are local. So you came to Bangalore, you are non-local, right? We are non-local, even I am. We are non-local. It means instead of moving data, you move the computation, which is easier. But if your data is moving, it means that is no data localization. In the old approach, we do not have data localization. We do not have data localization. Understand?
Sorry, in which
That is
ready?
Any doubt, guys?
no.
No, clear.
Clear. Now you do not have a data local. Now fine, okay, fine, I'm okay with the data localization. Let's assume that I'm okay with the non-data localization. Now this 50 GB data has to process in a single machine. The 50 GB has to process in this machine only. Is it a sequential process or parallel process? It's a sequential process, right? See, parallel process, how can you say like it is a 4 core or 8 core or 6 core, but a single machine only is getting processed, right?
Yeah.
So
there is no
single
parallel process.
CPU.
Yes, multiple CPUs I can say.
Yeah.
So no parallelism here. So why we need a parallelism? Let's assume that I have a 10 apples. Okay, I asked to Debajit to collect them. How many attempts you will do? 10 attempts. Every time he will pick 1, 1, 1, 1. So I have a 10 apples in 10 different boxes, 10 different boxes, 10 different computers. Let's assume that like I have a 10 apples in 10 different boxes and I ask the 10 people to collect them. Single attempt is enough, right?
Yeah.
For each person, single attempt. So I'll reduce the time. So to reduce the time, we need a parallelism. So I do not have a parallelism in a existing system. I do not have a parallelism in a traditional approach. Understand?
Yes.
I'm also okay with that. There is one more problem.
one more question.
Go ahead.
In this case, resource will be more than.
Sorry,
Resources will be more than.
these resources you're talking about.
No, he's asking about
10 systems.
Yes,
10 CPU
yes,
will
yes.
be there.
Yeah, we need the resources more. Correct. I'll come to that point. I understand. Though we are increasing the resources, the cost will increase. Very good point. I'll keep in mind that point. I'll explain. You'll only answer to me another few minutes. Okay. Now another problem. Let's say now I have sent my query. I have sent my query. While downloading the data or while processing it, my machine is failed. My data warehouse system is failed. Do I have a duplicate here?
No.
Is my job will success or fail?
Fail.
Job will fail. And there may be a backup. There may be a daily backup we may taking as an data warehouse system administrator or someone. There may be a person who is taking a backup, but that backup mission has to bring to a network, and this job directly has to go here, right? That's not possible in a traditional approach. So there is no auto fault tolerant. Auto fault tolerance means if one mission is fail, my job should not fail. Automatically another mission come and say, I am alive, you no need to worry about that, you just continue the job. Let's say
like
I have,
just
go ahead guys.
like recovery systems, right?
Not recovery system exactly. Let's say you, Debashish and Suman, two people are sitting.
Clustering.
Yeah, clustering. I'll come to that point. I have Debashish and Suman and Srikanth. We three guys are sitting, and let's I try to reach Suman, but Suman is not available. But I already came to that location, but I don't want to come back. I can talk to Debashish to get it done my work.
Okay.
Understand, right? That kind of mechanism
Yes.
is not there in a traditional approach. Clear about that?
Yes, yes.
And also you do not have, is there any option here by default the backup will be created?
No.
Let's say that I have a computer, I'm storing one file in this computer. Let's say I'm storing one movie. Okay, let's take any of the movie. I'm storing one movie in this C drive or somewhere in the computer. Is there any option by default it will store another copy in another machine?
No.
No, there is no auto replication. There is no auto replication. So here you are seeing scale up. Scale up is more costly than scale out. Scale out means increasing the machines like this, clustering.
Right.
Scale out means is going like this. The scale up means you are bringing a new machines. But a scale out means you are bringing a very bigger machine. You're replacing the very bigger machines. So here the other problem is no scale out. No scale out means you have that mechanism, you can do with MySQL. You can create a different instances here you can do, but it's a very difficult to manage. And if something is failed, the whole cluster will be not respond. Okay, these are the limitations. Not go ahead.
This scale out is like we are doing reporting in VA server. So in VA server also scale out option is there, like that same thing, right?
Yeah, BA servers are something different, which is for ETL, right?
Yes, yes.
Not for the storing.
No, this server means clusters in one node will be
That's a
one
cluster environment. So are you storing the data in it?
No.
That is not for the storing the data, right? That is for, I mean, the different kind of process. It can be ETL.
Yeah, for
That's
managing
ETL.
servers and yeah.
That's ETL. That's not a data storage. I'm talking about data storage.
Okay.
Okay. So these are the limitations I'm seeing with the traditional approach. So are you guys clear about traditional approach and what are the problems?
Yeah. So last one is scale out means it's exactly backup type of replication, right?
Not the scale out
No,
means
it's
not the replication. If the data is increased, you need to buy a bigger machine and replace this.
okay.
Understand, guys?
And that old and,
Yeah.
and the new bigger machine will hold all the old data, right?
Yes, the whole data has to again dump into new machine.
Okay.
So who is causing the problem here?
Storage capacity.
Not the storage capacity, data.
Okay, yeah.
Day by day it's increasing.
Data, right?
Yes.
Let's go ahead. The next slide. Next page. Let me show you. Who is causing the problem? Data,
The data.
which we say big data.
Yeah.
Which we say big data. What is big data?
So actually, day by day, the data is increasing, like from CC cams, from sensors we are getting. So
Mhm.
beyond that storage capacity, which is having the data, we call as big data.
Very good answer. Normally we'll say huge amount of data, right? But
Yes.
how much
Yes.
huge? How
I don't
much
know how.
huge? Is there any measurement for this? There is no
No.
measurement. There is no limitation. There is no measurement. All right. So can I say an example for you? Can I say 100 MB as a big data? Can I say 100 MB as a big data?
Yes, means if it concerns to the capacity is in 80 MB, then it may be a big data.
Very good question. Very good answer. I think you have gone through some of the either my videos or some of the videos in online. Very good.
No, 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 sir.
No. It's
Just based.
appreciable. See, before getting into new technology, if you do some background, understanding, or if you do some research, it's well appreciated.
Yeah, yeah,
We need to do that
yeah,
always.
sir.
Yeah.
Come on
So
here.
the 100 MB is I can say it's a big data with respect. See, how can I say 100 MB is a big data? Let's assume that I have a Gmail application or email application, not the Gmail. Let's say email application. Can I send 100 MB in email?
No.
I cannot send.
No.
It
Yes.
fails.
Yeah, limitation.
With respect to my
You
email
can,
application, this 100 MB is a big data.
Huge.
And can I transfer 2 GB or 3 GB data through a Bluetooth? I cannot.
take time, I think.
Yeah, it will take so much time. If something happened in between, the connection should be connected always, right? Something happened, it will go. It's difficult, right? So to transfer huge amount of data through Bluetooth, for the Bluetooth, that data is big data. So when you're saying about a big data, when you're saying anything as a big data, you should keep in mind that with respect to what I'm talking. If you take RDBMS, 1 TB or 4 TB or more than that, there is no limitation here. Okay, which is the data is not able to store, not able to store, not able to process. By using this approach, that data is big data for this. I have an application. That application is not able to process 100 MB of data. So for that application, the 100 MB is a big data. Let's assume that I have a 10 TB data. Let's assume that my 10 TB data is I'm not able to process or store or manage or process my data using RDBMS to generate the reports in 5 seconds. I'm not able to do that using RDBMS. So with respect to RDBMS, the 10 TB is a big data. The 10 TB is a big data. Whenever we say big data, with respect to what we are telling. So generally, general normal terms, when we say big data, we are telling with respect to RDBMS only, the traditional approach only. When I say big data, it means the huge amount of the data which is not able to process, which is not able to store and manage, process efficiently. This is very much important. Efficiently, we are not able to store, manage and process efficiently that data. We will say big data. We'll say big data. You got your answer for your question, Devasis?
Yeah. Yeah.
Now the big data. So what is the classifications of the big data? Classifications of big data. Not only big data, it can be normal data also, but generally anyway the big data came into picture, so we are explaining about the big data. So the data has been classified based on the schema it follows, based on the pattern it follows, based on the based on the data. They have classified into three categories. They have classified into three categories. One is structure, another one is unstructured, another one is semi-structured. Okay, let's take an example with the structured data. What are the examples for the structured data? What is the structured data? First of all, when you say structured data, the data has followed single delimiter or single schema. Delimiter means you guys understand, right? Delimiting. Suppose you have two fields, delimiting. Okay,
Comma, semicolon.
comma, tab, or the hash, anything. Okay,
Yeah.
understand, right? So here,
Yes.
so let's say an example is your DB tables.
Yes.
The DB tables are looks like columns and rows, right? So what is the schema here?
Yes.
Columns, number of columns, and
All RDBMS.
all appears your tables, views, whatever you take, all have a columns, right? One table may have 5 columns, one table may have 2 columns, but it's following some schema that is a fixed, right?
Yes.
Your Excel sheets, your CSV files, your TSV files. CSV means comma separated values. Let's say name, comma, address, comma, phone number, all the records. In all the records, let's say Ravi, Bangalore, some 999. So Veera, HYD, Hyderabad, something. Kumar, Pune, or something. So all the records are following comma, right? Single delimiter. Is there any other delimiter in this? No, only single delimiter. If you take your Excel sheets, how your Excel sheets looks? Columns and rows,
Yeah.
right? So if any of the data is following a specific schema or specific delimiter, single delimiter, that data will call as a structured data. Clear about the structured data?
Yep.
Yeah.
Then what is unstructured data? What is
Unstructured data like
what is unstructured data? Which will not follow any schema or specific format. A best example is audio, video, images. These are the best example for unstructured. Go ahead, guys. I think you are telling
We
something.
can say some paragraph also, right?
Sorry?
No, paragraph also means some
No.
paragraph. Yes. There was
Paragraph. You're talking about text
paragraph.
file. You're talking about text file, right? It can be a Word document or something.
Yeah.
As per my
But text
knowledge,
file will
sorry?
be coming under structured data, right? Text file.
No, it will not come under structured data. Why it will come under structured data?
So we
Let's see.
can in the DD we can means extract
Let's see.
from
Let's see. I have here 3 different structure files. This is one structure file. This is one text file. This is one structure file. Okay. This is one text file, and this is one text file. Okay. I have 3 text files here. All three text files are following the same pattern.
No.
All these 3 text files are having the same. I have one more text file here. This is another text file. All are following the same thing. Here I have something.
No.
Here when I see here I have something, When I see here, I have some paragraph and headings or something is there. When I look at this, I have something else, right? So how can I say structure? If you take any table, if you take a MySQL table, if you take a SQL table, if you take a Excel sheet, if you take anything, I'll show you the same number of columns or columns. But how can you say it's a structure?
Yeah.
Correct, right?
Yes.
So the best example for unstructured is audio, video, and images. So coming to the semi-structure, the best example for semi-structure is text files, because semi-structure means when I look at the data, I will not find any structure, but it is following internally, it is following some structure. Internally, some structure is following, not the whole data, the part of the data is following some structure. Let's assume that if I take this text file, okay, this word and the next word, what space is. So these words are following. If you take any two words has a space. If you take any two words has a space.
Yes.
But when I look at this file and when I look at other file, those are not following the same. When I look at this, it has something else. It has a paragraph, it has something else, it has a heading, so something else is there. But what is the common there? Every two words has a space. Agree?
Yes.
So can I say semi-structure? Text file is a semi-structure.
Yeah.
And your emails.
Yeah.
Semi-structure. Your Word document.
Mm.
Semi-structure. Your log files. Do you guys get a chance to look at the log files anytime? Log files.
It will be text file only.
It will be text only, but when you look at the log, let me show you one log file. Let me show you one log file. It will be very much. It will make you clear idea. This is not the one. Let me show them.
If you query also LSI, then LRT
Sorry?
If you query also in Unix, LSI
Correct.
LRT or file also, that will be one log.
This is a log file, right? You guys able to see here? This is the log file. This is a log file.
Yeah.
So when I look at this file, Ravi, I have a date, time, type of the log, and I'm getting some class. Proper delimits are there, right? Everything is following space only. Proper delimiter is there. Why can't I say it is a structured data? If you see, if you take any file in this, any log file, you'll have a column 1, you'll have a column 2, you'll have a column 3, you'll have a column 4, or you have a column 5, like that, right? There may be a number of columns, may less or more, but all the data, see, you forget about this. These things, something like which I have written sysorts. For actual data, these are the actual logs, info, warn, debug, or some different kind of logs. They all are following the same structure, or all are following the same structure.
No, actually the spaces between two words also not exactly.
No, this is correct space, this is also correct space, this is also correct space, and this is also correct space.
Here it will be like
no, spaces are there, but not having same length. Length is different.
No, the same line only. That's no, that's not the point. So actually, when you write a log, I think you might get an idea. Let me show you that. Okay. So how we will log will so how we will design a log file. The first we will be having a date or else IP address, like IP address and date, time, and this is common delimiter. This will be tab or space, single space or tab. So that will be common. Okay. Let's take a space. These are different field, time and the log type, space, and some class name or something xyz. So proper delimiter will be there, space. Okay. So It has a column 1, column 2, column 3, column 4, column 5, column 6, column 7. So proper columns are there, no? How can I say it is not a structured data?
Because in log file, different files would have been different extensions.
Not, that is not the one. So you need to consider only these columns. If you take a tables,
Okay.
one column may have different value, one column may have different value, no?
Yeah.
But the columns are
But yes, yeah.
columns are correct, right? But here, Mike, what I'm trying to say, when you look at the successful log, this is successful log, right?
Yeah.
I don't have any errors in this log. That's why I got the successful log proper delimitation. Column 1, column 2, column 3, column 4, column 5, like that properly I got the data, right? But if any failure log, if you look at any failure log, let me make a failure of this text, this example itself. If you look at any failure log, if you look at any failure log, I need to remember again, I need to change this. If I look at any failure log, is there any structure here?
No structure.
This is failure log. Is there any structure here? No structure, right? So when I say the log files are structured, all log files has to same, right? Whether it's a failure log or successful log, the all log files has to go with the same structure. But when I look at this kind of things,
Same format.
sorry?
Means that means same format.
Yeah, exactly.
Right? Same schema is.
Exactly. So in this case, it is not following same schema. You understood, right? What I'm trying to say?
Yes, yes.
So
If structure, in any case, like, whether it is success or a failure log, it will be same. But in this case, it's not.
yeah, exactly. So that's why I can say my log file is a semi-structure, and I have a XML file. XML file semi-structure or structure,
Semi-structure.
and I have a JSON files. Do you guys get a chance to look at the JSON files?
No.
JSON files are something like, okay, I have JSON files here. Some JSON files like here. Sorry, guys.
No.
The JSON looks like this. Okay, if the bracket open, there will be on key value, key value, key value, key value, key value. The JSON files will be looks like the bracket will open, and there will be one key colon value, and there will be one more key comma value, key colon value, and our bracket will be closed. You can say, Ravi, when I look at the JSON file, it has a super structure. There is a key associated value, there is a key associated value, there is a key associated value. Then how can I say it is unstructured or semi-structure? How can I say it is a semi-structure? It is a structure. It should go under the structure. The problem is here, your value is there, no? The value can be again a key value, or your value can be again array of key values, right? This value can be again array of values or array of JSONs, again sub JSON it can have, right? So that's why your JSON files are semi-structured. Are you guys clear about the classification of data?
Yeah.
Now, characteristics of the data. Let me move characteristics of big data. The 6 V's we are talking about, the 6 V, no? 3V, 6V. The characteristics of 6, that's called 6V. The first V represent volume. The second V represent velocity. The third V represent variety. The fourth V represent volume, velocity, veracity. Not validation, I'll tell you. The fifth V represent variability. The sixth V represent value. So you guys understand by names itself, right? The first V says volume, how much data you are dealing. 10 TB, 20 TB, 100 TB, 1 petabytes, 2 petabytes. That volume will be represented by first V. Okay. Second V is represented by velocity. Velocity
Speed
means,
of network.
yes, how fast the data is getting generated. Your 10 TB data, how fast it is generated. If you take 80s, to generate 1 GB data, they may take on so many days. In 90s, to take 1 TB data, they have taken so many days. If you take now, current, the Facebook alone, it is giving you 100 TB in a day. The Twitter alone is giving you more than 100 TB in a day. The YouTube itself is giving more than, I mean, it's every second, every minute, they're getting 40 fresh videos, 40 hours of fresh videos. Each video will be having minimum 200 MB. 40 into 200 MB. 8000 MB. That means 8 GB data in a minute. In a minute. I think in a minute or second, not exactly the remember that, but it's not matter actually. We don't need it. So I'm telling you, the huge amount of the data is getting generated very fast. That's the velocity. The third V represent variety. What type of data? With the structure, unstructured, semi-structured. So if you made a cluster using Hadoop, you can handle any type of data. There is no restriction. Hadoop will not follow a schema to store data, but your RDBMS follows the schema or not?
Yes.
It should have a schema, otherwise there is no point to store the data in RDBMS. And veracity. So veracity represents how accurate the data is, how trustworthy the data is. So now the best example, nowadays we are seeing the Kaveri war in the Bangalore is running, right? The Kaveri war, or the Kaveri Karnataka versus Tamil Nadu. What they're talking about? How will you know? By seeing the hashtags. You'll be seeing the hashtag like this. Kaveri war. Sometimes you'll be seeing KA versus TM, Tamil Nadu. Sometimes the very popular one, you will be seeing IND versus Pak. So what they're talking about? Are they talking about any war? Are they talking about any match? Are they talking about any business between these two guys? What they're talking, how trust the data is, how accurate the data is, right? So that type of data also you can handle in your Hadoop. And variability. Variability means today I'm getting the text files. Tomorrow it may be a log file. Tomorrow it may be XML file. Tomorrow it may be a videos. Tomorrow it may be audio, right? So the variable is keep changing. The format of the data can be changed frequently. You no need to replace your cluster can handle it. The final one is value. Value is the most important thing in the world, or most important thing in the big data world as well. Some people will tell you only 3 V's, some people will tell you only 4 V's, but actually it is the 6 V's. Value is the most important, very much important. Why we are learning Hadoop, guys? To added advantage, to give some value to our profile. No. Why we are learning Hadoop? To give some, to give a value to our profile, to give a value to our career. The value is whatever the data I have processed, whatever the data I have analyzed, that should give you a value. That should give some value to your business. If you're not getting any value, what is the point, right? If you're not getting any value by learning Hadoop, let's assume that. What is the point to learn? Why to waste a time? Why to waste a time on money? Money is forget. You can earn money anytime. Money is not matters, but time. Why to waste a time? So value is the most important factor, most important V in the 6 V's. Okay. Actually, I used to give an example, a kingdom, an example, but that we are running out of time, so I need to take my kid to hospital. So I'm skipping that example. Okay, we will see. The simple example. Let me finish that example. The example is there was a king who is an Indian king. I don't know who is the king, from where he is. There is a king. Okay, the king went to UK, and you guys know Royal Rossi is the biggest brand. The
I know this.
Yeah, you might have heard about the story, yes, in the Facebook or here and there, right? So the king went to the
Yeah,
Royal
actually,
I mean, let me finish, Srikant, then we'll just really get into that. So that king went to Royal Rossi showroom. He didn't get a proper respect from the salesperson. Okay, because the kings and leaders will always expect the respect. Okay, they need the respect. Everyone should fold their hands and bend in front of them. And he didn't get the proper respect. Then he felt very bad, and he come back to the hotel, and he called his PA, and he booked all the vehicles. I mean, 6 vehicles. I think 6 cars were available in the showroom. He booked all the 6 Rolls Royce vehicles. Then the salesman was very happy. He was not. He don't know who booked it, and he was very happy because he booked all the cars on his name only. Then he's waiting for the who is that guy, who is that big shot. Then the king entered into the showroom. Then the salesperson felt guilty himself, and he felt bad. And fine, though he paid whole amount in a single shot, and he take the vehicles and come to India. Then once he come back to India, he started using those cars for sweeping the roads, collecting the garbage, like our BM, no, how your Bangalore municipal vehicles are running. He has used for that purpose. The brand value of that Rolls Royce is gone down actually, so it's gone very bad. It's a drag down to very badly. Then the social media, those days no social medias, at least those was, there will be some media over there, right? So then it has been moved worldwide, the news has been spread worldwide. Then the sales of the Rolls Royce has gone down because the people think that it's a bad product, right? So let's assume that the Sachin bought iPhone 7, and he gave a statement, awesome phone, excellent phone, XYZ, and everyone would buy. And let's say Sachin said that's his worst phone. Do you think how much sales will go down? All right. So like that, the sales has gone down. They analyzed it, they realized it, and they found because of this. Then they come back and they have apologized him, and they have compensate another 6 more cars by taking these old cars. So they have done something. So here, what is the matters? The value. The values matters, right? So
Yes.
the
yeah.
value is very much important. Yeah, go ahead, Srikant. You were about to tell something. I stop you in middle.
No, no, that is
Okay,
fine.
fine.
I thought nothing.
Okay. Now let's go ahead and
Let's go ahead.
okay. Let's go ahead and look at Hadoop Hadoop architecture. Hadoop is a solution, a framework which stores, process huge amount of the data in efficient manner. Hadoop is a Java-based framework. Hadoop is a Java-based framework which is meant for store and process huge amount of the data in efficient manner. Our Hadoop come up with two beautiful components. One is, let me draw here. Our Hadoop come up with the two beautiful components. One is HDFS, another one is MapReduce. Okay guys, the history we are going to cover later point of time. We don't need the history. When 2002, 2004, 2006, 2000, that years and all we don't need to remember. I'll explain the history later point of time. I have well documented history. We will see that history later point of time. The HDFS is meant for storing the data. The MapReduce is meant for processing the data. HDFS stands for Hadoop Distributed File System. Hadoop Distributed File System. MR is nothing but map and reduce. So it is not telling anywhere I am a database. It is telling I am a file system. What is your HDFS? HDFS is a file system. It is not a database. Now try to understand. Ravi, already we have a file system. Then why we need a new file system? What are the file systems we have? We have a file system called
NTFS.
sorry?
Okay. No. I was saying NTFS,
Yeah.
FAT.
I have a local file system. Local file system, anything is a local file system. Okay. So which is local to your operating system, your operating system will have more control on it. Your operating system will decide it, how to write the data, how to read the data. That's the local file system. That is local to your operating system. Okay. In the local file system, your data anywhere, not only file system, any disk anywhere, the data will store in the form of blocks. In the local file system, the block size is 4 KB. The block size is 4 KB. And I want to ask one question here. Can you change the block size here? From 4 KB to I want to change to 100 MB. Can I change here?
Yeah, in local. I
Sorry?
think we can change.
We cannot change.
I think we can.
The block size
Oh.
in the operating system.
It will be depends on your microprocessor.
How will you change that? I mean, being a developer or being a user, I mean, your voice is not clear, Suman. We cannot change, right? Can we go ahead and change the?
But it will be different on different microprocessors.
That's correct. But can I change it? Being a user,
No.
we cannot
No,
change.
being a user, we can't change.
That microprocessor also, when you built it, when you design OS, that's belong to OS only. OS will have command on it, right? And so when I store the file in this local file system, let's assume that a C drive. The same question. I'm storing one movie or one PDF. Can this PDF can be replicated twice or thrice? Can I change that? So let's assume that I'm using Linux box. As soon as I store in the Linux box means it should come to root user. Okay. So as soon as I load any file in this under the user, it has to replicate 2 copies. Can I do that? Can I say that? We cannot say that in a local file system, right? The local file system, your block size is 4 KB, and you will not have this kind of duplicate, taking the duplicate. You will not be having control. They simply say that you will not be having control. But when you go with the Hadoop, there is a file system called HDFS, Hadoop Distributed File System. This is a virtual layer. Even this is also virtual layer. You cannot see this. You cannot see even OS. You can feel it. Okay. You cannot see that. Okay. So it's a virtual layer on top of the local file system where the Hadoop user has more control on it. Where Hadoop user has more control on it. If as soon as you install the Hadoop software, your block size will be 64 MB. It is Hadoop 1.x. Hadoop 1.x, so 64 MB. Hadoop 2.x, it is 128 MB. The block size. Where is the 4 KB? Where is the 64 MB? It means in local file system, your operating system is saying that you read the 4 KB block at a time. You write 4 KB block at a time. But here we are telling to our cluster, we are telling to our file system, my file system is capable enough to hold or read, write 64 MB file. I mean 64 MB block at a time. Okay, and whatever you store in this file system, I'll copy thrice by default. I'll copy 3 places by default. I'll copy 3 places by default. These kind of facilities. Tomorrow 64 MB. I don't want 64 MB. I want to make it 100 MB. I can go ahead and make it. Yeah, go ahead, Srikanth.
Yeah, 3 times is a default replication factor.
Exactly.
Right.
Exactly. We can go ahead and change it. You can make it 1. You can make it 10. You have a control on it, but you don't have a control on your local file system. That's what I'm trying to say here. Okay.
Yep.
Understand, guys?
Yeah, one question is in HDFS. Yeah, someone here. In HDFS, if the block size will be like regarding consent to the data, if 20 KB or 2 KB or 4 KB or 8 KB will be there, so other spaces will be wasted.
No, nowhere. It will occupy only that. But here the block size is that much. What is the block concept came into picture? Because at a time I can process that much data. At a time I can read that much data. If it is lesser than that, I'll read lesser only. I'll not waste any memory. If you start wasting like that, so we end up with so many machines.
Yeah.
Let's say your pen drive. Okay, your pen drive block size is let's assume that 10 MB. Let's assume that. Let's assume that. If while you are copying data, you have a small file which is take 1 KB only. When you put 1 KB but it occupies 10 MB, so what about rest of the 999 and so much of data, right? 9 point so much of MB data. What happened to that?
It will be occupied if other data transfer will be happened.
It will not occupy. Okay, suppose if I store here, let me take an example, 64 MB. If I store only 30 MB, my block size will be shrink to 35 MB only, 30 MB only. In this case, my Hadoop will treat the block size 30 MB only. If you have more than, let's assume that I have a 66 MB. Let's say I have 66 MB. In this case, it will create two blocks. One block is 64, another block is 2 MB.
And yeah, 2 MB.
Understand, right?
Okay, regarding to the size, it will create.
Exactly. Understand?
But in case of local file system, if
it's always 4 KB.
Yeah, always 4 KB. If 9 KB file is there, then it will create
two blocks. Yes, correct. That's a three blocks. Yes, yeah. That's correct.
So maximum 3 blocks.
No, maximum 3 replications. Now, let's assume that I have Amazon file. Now I loaded Amazon into /user/Ravi. Let's assume that. Okay. What it will do here, anyway, the HDFS is form of the multiple missions, right? Multiple clusters, multiple missions will be there. So I not yet come to that point, because to answer your question, I'm going to tell you. So this Amazon file, right? One copy will be there in this mission, one copy will be there in this mission, one copy will be there in this mission. So 3 copies will be there. If one of the mission fails, still we have 2 more missions. We have 2 more copies. Okay, that is a replication factor. That's called replication factor. Okay.
So in case of we are extracting data from, we have 3 copies in 3 different machines. So while downloading the data from one machine, if it got failed, right?
Yes.
Then it will automatically come to the second machine, or we need to.
No, automatically it will come. It will come automatically. That's the beauty of Hadoop.
So machine means that is HDFS one system, right? So
sorry.
Actually, there will be one system, no, that HDFS.
No. HDFS is collection of missions. Actually, I'll come to that point, guys. So I don't want to make you confused. Just wait few minutes, and you will say that the answer. Okay. So the HDFS follows one specific architecture. The HDFS follows its own architecture. What is that architecture? To form that architecture, we need 2 nodes. What is a node, guys?
Mission.
A physical machine which is participate in the network. The machine is called a node. It can be any machine. It can be your laptop. It can be a normal machine. It can be a machine in the rack. It can be a machine in the cluster. It can be anything, right? A physical machine. A node is a technical term of the machine, physical machine, which is participating in the network. Okay. And to form HDFS architecture, we need 2 nodes. One is master node. This is master. And another one is slave nodes. This is a slave. One is master node. Another one is slave. Okay. Before getting into this architecture, let me give you a very simple real-time example. So we are working in an IT company. We have a team. We are working in a team. Who is our master in the team? Our manager.
Lead
or manager. Ideally manager. We'll take as a manager. And who will be the I don't want to call as the slaves, but who will be the the actual worker? Team members. Yes, team members. So my question is that here, he is your master, your manager. He is just going to take a development work himself, or testing work, or anything work himself. Will he participate in the development work?
No,
so he has enough work to do a managing, right? He should understand, oh, Devasis, oh, he's strong in SQL. Oh, Suman, he's strong in PLSQL. Oh, Srikanth, he's strong in somewhere. Oh, Ravi, he's strong in something else. He has to maintain all this information, the metadata information, right? Oh, Devasis will be in leave from this date to this date. Okay, so I should not assign any work to him. Oh, he's doing this current work. Oh, correct. Okay, fine. So this all the metadata information has to keep, right? He has to maintain, right?
Yes.
So your manager will not do actually development or testing work. Most of the managers. So why they will not do? Because they have enough other work. They have to maintain some, SLA. They'll be having so many things. Okay. The same way here, we have something called a master and we have something called slave. The master, will call it as a name node. The slaves we call as a data nodes. We'll call as a data node. The slave nodes will call as a data nodes and the master will call as a name node. Why will call as a name node? Why will call as a data node? I'll be telling you now itself, not to worry. So the name node will maintain the metadata. This guy will maintain the metadata. This metadata contains, like our manager maintains Excel sheets, right? The same way. This master machine maintains a metadata. That metadata contains what is the data is there in my cluster, what is the data is there in my cluster, what are all active, what are the alive. See, these machines are all in network, right? So let's assume that this is 1, this is 2, this is 3, this is 4, this is 5. These are all network. There may be a chance some machines may fail. What are the machines are in the network, what are the machines are fail, all this information maintained by a metadata. What is the machine is currently doing, what process it is doing, what is the data it is stored, the data is belong to whom, all the information will maintain by a metadata. Okay, the metadata will be stored by the name node. Why we call this a name node? Because let's assume that I have stored a file called Amazon. Let's assume that I have stored a file called Amazon. Let's assume that I have stored a file called Amazon file. The file will be divided into blocks because HDFS cluster will load into form of the blocks, right? Your HDFS, not only HDFS, even your local file system also divided into blocks initially. Then only one block it will read. But HDFS also, it will divide the data into form of the blocks. Okay. Now, before that, so in this machine you have installed Hadoop. In this machine you have installed all the machines, you have installed Hadoop. So because of it is a distributed file system, because of it is a distributed file system, mobile, because of it's a distributed file system, it will treat it as a all the machines are single hard disk. Okay, before that, actually I thought to give the difference later, but anyway the time is came, I would like to explain here. So let's try to understand what is the difference between DFS and HDFS. Do you guys know what is the distributed file system?
Yes.
So what is the distributed file system?
The files will be distributed across multiple machines, and it will, but appearance will be looks like
Single.
it is in same single machine.
Exactly, very good answer. So data will be distributed to multiple machines, but it looks like it is in a single machine. Let's say, let me give a small example here. I have a machine called employee machine here. I have a machine called employee here. I have a machine called student here. I have a machine called projects here. Okay, but all connected to internet. All are connected to internet. These are the different machines, but I am a user client here. From the client, when I www something /employee, when I say, the data will come from the employee. When I say student, the data will come from the student. When I say projects, the data will come from the projects. So here the data is here in the network, in the dedicated machines. This is DFS, guys, distributed file system. So the data is in different machines, but for me, for the client, for me it looks like a single entry, right? For me, it looks like a single entry. When I want to store some data into employee, when I say /employee /employee / some folder, will say when I want to store some data into students class, like that I'll say. But this everything is single entry for me, no? Single entry. The same way here, when you install the Hadoop software in the multiple machines and connected each other, it will act as a DFS. It's actually HDFS, Hadoop Distributed File System. Okay, underneath, actually underneath, how many machines are there? 1, 2, 3. But here underneath, I have multiple machines. 1, 2, 3, 4, 5. The same way like our distributed file system. Now you may ask the question, Ravi, already I have a DFS. Then why should I need a HDFS? Why can't I go with the DFS only? The problem is here, the DFS, the same kind of limitations that we have seen in the traditional approach. It's a single machine, no? The whole data will go into single machine. If this machine fails, I don't have a duplication. If I want to get the data of the employee, it's a sequential process. When I submit a job, the data is not available, the job will fail. By default, the data will not store duplications. So these are the limitations with the DFS. That's why the HDFS is popular than DFS. Are you guys clear now? Debashish and Suman.
Yeah, yeah.
Okay, now so when I connected multiple machines, when I install a Hadoop, so it will act as a single entry. It will act as a single entry. Okay, underneath I have multiple machines. Here I have only dedicated machine for the dedicated things. For employee I have a dedicated, for the student I have a dedicated, for projects I have a dedicated. But here there is no dedicated for dedicated missions. Here all the missions are shared across. Let's say I'll show you an example. Now we will be very much clear about it. Let's say I have amazon.log file. It is a 1 GB data. It's 1 GB data. And my block size is 64 MB. Let's assume that my block size is 64 MB. How many blocks will come, guys? 1024 MB by 64 MB, 64 1, 64 16 point something, 64 2 for something. So close to it will come 17 blocks. Am I correct, guys? Your
Yes.
whole Amazon data will be 17 blocks, like block 1, block 2, block 3, block 4, 5, 6 and so on, block 17. Right? Now when you load this data into HDFS, I'm not going very detailedly. I'll be showing the rightful later point of time. We'll be having a client here. One client machine will be there. We'll be loading the data from here. Okay. So when I load this data into HDFS cluster, what it will do, your client machine will take the first block. Your client machine will take the first block. Then it will go to the name node. 1 second, guys. Does anyone is dropped?
Yeah, no.
Actually, it's only connected.
Okay, fine. So,
For 5 minutes, for 5 minutes.
I will do one thing. I'll keep you on mute. Okay. Then you guys can clearly listen me. Okay.
Ravi, it's got disconnected.
Right now it's okay.
You were explaining HDF, that DFS.
Yeah.
Okay. Now it's
Single
fine.
entry you were telling about.
Yes.
Yeah, fine.
So are you guys on the same page?
Yes, and
Yes,
last 3 minutes we are not able to hear because the network got disconnected.
Oh, sorry guys, I was not aware of it. Okay. So now the Amazon file will be broken into 16 pieces, 16 or 17 pieces. So the first piece will be taken by your client. The client will go to a name node. Like, let's say a new task come to our project, new RC, change, some new requirement came. Okay, requirement change, some new requirement came. So he will contact whom? Your client will contact a manager, right? He will not contact directly an employee. He will contact to a manager or a team member, not employee, team member. He will not directly contact a team member. He will contact to a manager. Then he will ask, oh, I have a UI work. Who can do that? Then your manager will refer the metadata. Who is strong in that? Normally he knows that who is strong in the UI part. Then he will give his name to your client, right? Are you guys able to hear me?
Yes.
Okay, guys, if any network problem is there, please let me know. Okay. So then your client will go to approach to manager, and manager will talk to he will look at his metadata. Okay, this guy is free, this guy is strong in UI, and he will refer that name to client, right? He will refer the name to client. Then client will assign the work to us normally. Here also same approach. It will take the first block and it will go to the name node. After going to the name node, it will tell that hey master, I want to load Amazon file. This is the block. What is the file? What is the file? Amazon file. Amazon file. Amazon file. This is the block. Block 1. So I want to load, this is the block. My replication factor is 3. Replication factor is 3. It means 3 copies. Then your manager is there, no? Your node, your name node. What your manager will do, he will refer the metadata and he will identify 3 missions, because we need 3 missions, no? 3 copies kada. Sorry, you guys can following. So 3 copies, right? We need 3 copies. So this guy will identify 3 missions. So you may ask, Ravi, how you will identify? He follows an algorithm called rack awareness and block replacement policy. Block placement policy, I can say. Block placement policy. What is this block placement policy? So what is the rack awareness? So you guys get any chance to look at the cluster anytime in Yahoo rooms, in offices, Yahoo rooms,
Yeah, cluster.
Server rooms.
Microsoft cluster, you are saying?
Yes.
We are aware of Chrome, but we never.
Okay, fine. So it's okay. I'll just tell you that. Okay, there will be switches here. These are the racks.
Yep.
And there will be one more switch here.
Public IP and private IP.
Correct. So these racks will have the missions. These racks will have the missions like this. So in Hadoop cluster also, when we form the Hadoop cluster, we'll define the racks and which rack it is, which data node it is, and all those things. Okay, I'll show you the diagram, guys. The real-time diagram. So racks will be like this: rack 1, rack 2, rack 3. Rack awareness, what it says, take 2 missions. Okay, this is the nodes. Let's assume that this is name node and this is the data nodes. These are the data nodes. Okay, these are the nodes. Node is nothing but a computer, no? Now here, your name node, rack awareness says that take 2 missions from one rack. Mission 1, mission 2 from one rack. Take other mission from other rack for copying. Why we need? If this mission is failed, I have one more copy in this. If complete rack is failed, I have one more copy in the other rack. Understand, right?
Yes.
And your client will be from this rack only, these racks only. Your client can be any of the mission from this rack. The client can be any of the mission from rack. The client can be any mission. This mission can be client. Or this mission can be a client. Or you can have a dedicated mission in the client in the real time. In the real time, you will be having a dedicated mission for the client. Okay. Now, what your name node will do? Who is near to the client? Who is near to the client? Let's assume that this guy is near to the client. His name is 5 and his name is 6 and his name is 7 or 10. Okay. What your name node will do? First, you will choose 5 and 6 because the client, if it is near to the client can easily store the data, no?
Yes.
Right. So this your name node chooses the who is near to the client, those missions. Let's assume that 1 and 2 and 3 are the near to him. Then he will take the mission IP address. These are nothing but IP addresses, and your client will talk to that mission. Your client will create a pipeline, data pipeline, and your client will start sending the data packets. 64 KB packets. Actually, the block size is 64 MB. In the network, we cannot send the whole data at a time. No, the data will go packet wise. The packet will have a header. The packet will have a tail, acknowledgement, right? So that first it will connect to the data node 1. The data node 1 is already connected to each other. So they will be connecting like this. The data node 1 will connect to this guy. The data node 2 will connect to this guy. So first packet will come here. It will store the first packet. The same packet will be copied here. The same packet will be copied here. So once this store successfully, these guys will report the name node saying that successfully we acknowledges. First they'll acknowledge to the client, and once the data is stored successfully, this line will be deleted. Now these guys, as soon as they load the data, as soon as they got the data, they have to report to name node. No, so see, as soon as what we will do daily, we'll be having a daily stand-up meetings, we'll be having the status mails, right? We'll be sending the status mail to our manager, right? The same way, your data nodes, why we are calling the data nodes? Because these guys are actually storing the data. That's why we are calling them as a data nodes. These guys are actually storing the data is here, not in the name node. We don't store anything in the name node. We store the data in the data nodes only. That's why we call it a data node. Okay, this data nodes will report to a name master saying that yes, I got the block 1, which is belong to log file, which is belong to Amazon log file. Block 1 came, the next block 2, next block 3, and your name node is there, right? Your master, you'll keep and make the entry. Oh, block 1, oh, block 1 is belong to data node 1. I mean, it is stored in the mission 1, it's stored in the mission 2, it's stored in the mission 3. Block 2 came, oh, it is stored in mission 2, mission 3, mission 4. Block 3 came, oh, this is called file to block mapping. File to block mapping. This is called block to data node mapping. This mapping will be there where? In the name node. Guys, are you guys confused or guys following?
Yeah.
Following, right? Your name node maintains metadata of file to block mapping, block to file. Why it is maintain the mapping? Suppose tomorrow I want the Amazon file. So when I say Amazon file, it will look for the how many blocks are there. Oh, 16 blocks are there. Good. So where the blocks are there, it will refer this one. Oh, here the blocks are there. Then read one block from here, read one block from here, read one block from here. All you read and it will hand over to us. Okay. Now the whole file is stored on all these missions. Let's say. Now if one of the mission is failed, this mission is failed, still I have a copy here. I have a copy here. Okay. Are you guys able to follow?
Yes.
Now when I load the data into cluster, I'll be specifying the path. No, see here how I specified employee / something I specified, right? The same way I'll be specifying some path here, no, while I'm loading the data. Let's assume that user / Amazon / data1 dot log. I have loaded this data. Now this is the path. Okay, this is the path. Under this path, the data is gone to so many missions. Yeah, 1 mission, 2 mission, 3 mission. So this is the path. Under this path, so many missions are there. Correct? Correct? Now when I want to retrieve, if you know the path is enough. If you know path where a file is, it's enough. Under your Hadoop will take care of pick one block from here, one block from here, one block from here, one block from here. It will take care of internally. Okay, and it will make a file and it will give a file. Okay, you should know only the path. You should know only the path. All right. So your name node maintains path information. The path information. What is the path? So your name node maintains the path information. How the path will look? Root. Under the root you will be having a user. Under the user you have a Amazon. Sorry guys, let me take a next slide, white screen. So how the path will be represented internally in inode, root, and root will have so many folders. Let's say folder 1, folder 2, and /user. Here the user. Under the user I have Amazon, I have eBay. Let's say under the Amazon data 1, right? This is what is this? Is this a tree structure? Is this a tree structure? And this is called a namespace. Your path is called a namespace. Your path is called namespace. Your name node is maintaining the namespace. That's why this node is called name node. Why we are calling the name node? Because he is maintaining the metadata in the form of tree structure or namespace. That's why we'll call as the name node. These guys are actually storing the data. That's why we call them as a data nodes. Are you clear? Why we need a data node? Why? What is the data node? What is the name node?
Yeah.
Right. These data nodes, right, in the team. So we are in a team. So in the team, we'll be keep telling, I have done this, I have done this, I have done this, like this. These data nodes will keep send the heartbeat, because they should know, no, your master should know your whether you are offline or whether it's online.
Yeah, node is alive or down.
Yes, the node is alive or not, right? Like that, your nodes will be keep sending the heartbeat. Every 3 seconds, it will send the heartbeat. What is the duration? Every 3 seconds, it will send the heartbeat. Every 3 seconds, heartbeat. Every 10 seconds, block report. What is the block report? I have stored this block. This block is belong to this file. I have stored this block. So every 10 seconds, it will, if any block is there, that's what. So I have these are the blocks. I have these are the blocks. I have these are the blocks. Why he has to send the block report? Because whole process will go where? RAM.
And
RAM. Any mission's RAM. So your name node should know. Your name node should keep in the mind. Right? It has to keep in the mind. Mind is nothing but RAM here. Okay. So your name node should maintain all the complete status. Complete state of your cluster. Healthy cluster. Your complete state of the cluster should maintain the RAM. That's why whole information will be there in the RAM. Whole information will be there in the RAM. If your mission restarts, if your mission restart, all the connections will be cleaned up. Why? Because your RAM will be cleaned up. No, nothing will be there in the RAM. That's why if you restart your mobile, no, none of the applications will be running. Right? So there is other process. We'll talk about that scenario when the name node restart, what will happen, how it will recover and all. We'll talk about that to next class. Okay, restart.
okay.
Okay, here we just remember it's not restarted, it's an alive. Now your master is managing the cluster in the metadata. Your data nodes are store the data in the form of blocks, right? So how it is efficient than my traditional approach? How it is efficient than my traditional approach? What is the traditional approach we have seen here? This is my traditional approach. How it is efficient than my traditional approach? The first limitation I have said, cost. To form Hadoop cluster, I don't need dedicated hardware. The first thing is I don't need dedicated hardware. The Hadoop software is open source. Hadoop software is open source.
Open.
So the less cost is less. And also you may ask, I think Debashish said, Ravi, you are increasing the sources for the parallel processing. You are increasing the number of resources. Correct. Here to increase the number of resources, I don't need a dedicated hardware. I can have a commodity hardware. Commodity hardware. What is a commodity hardware? Cheaper hardware. Cheaper hardware. What is the cheaper hardware? The hardware which is our 64 GB RAM, 64 GB RAM. It's greater than 64 GB RAM. It can be possible 32 GB also. It can be possible 16 GB also. I'm just giving you a best example. And 1 TB or more than that hard disk, or 500 hard disk also will work. And other one is processor. It can be 8 core, 6 core, or 4 core, or 32 core processor. Ravi, 64 GB RAM is small for you. Probably you are a big shot. No, for me it's a costly, but for organizations it's cheap. And also, as I shown in the rack, right? I'm not going to buy a monitor, guys. I'm not going to buy a keyboard. I'm not going to buy a mouse. That's why this is cheaper. If you buy a laptop, half of the cost you're putting for monitor only. Half of the price you're going for the multimedia keyboard or something this. Here it is just an hardware which it contains the 3 components: RAM, hard disk, and processor. I think Srikanth can help us to understanding better way because he is administrator. Srikanth?
Yeah, we use KVM switch, so we can handle multiple nodes in one
Rack.
keyboard.
Yeah, one keyboard.
Yeah.
That's correct. So whole rack we can maintain with one monitor, one keyboard.
Yeah.
Correct, right?
Yes.
So that's why it's cheaper. So the very first limitation, cost we have reduced so much. The second limitation is time. Here the data is there where? In the data nodes. Suman, Debashish, are you guys able to follow?
Yes.
Okay. So the data is there in these machines. When I want to process this data, when I submit a job, my job will come here and process. My job will come here and process. My job will come here and process. Because block 1 will be processed by here, block 2 will be processed here, block 3 will be processed here, and so on. So different blocks are getting processed by different machines. So parallelism is there. Parallelism is there. So
Yes.
am I moving the data? Am I moving the computation?
Moving the computation.
So time is less.
Yes.
And the third one is data localization. So wherever the data is there, I'm processing there only. So I have a data localization. And I have a parallelism. I have a parallel process. The fifth one, let's assume that one of the data nodes failed, but my block 1, so let's assume I'm processing the block 1, the machine is failed, the block 1 is there where and all, the 2 is there, 3 also there, so my job will not fail. So my job will be launched here. That is called speculative execution. We'll talk more about it, not to worry about it. This is not the last class with the architecture. We'll be keep talking about the architecture, so don't worry if you miss something. So if one of the data nodes fail, the same block will be there some other place, so the job will be launched that place. So auto fault tolerant is there. What is that? Auto fault tolerant is there. And duplication, as soon as I store the data, Amazon, instead of storing one place, it is stored 3 places. You may say, Ravi, instead of 1 GB it is taken 3 GB. So storage is not at all matters these days. At least these days storage is not at all matters. What is the cost of the 1 TB, guys? 1 TB hard disk?
Around
3 GB,
4,000.
3000, 4000 only.
Extra.
Yeah.
Yeah.
Even internal also, it's not more than that. It's also close. So based on the company, if you go Seagate, if you go Transcend, depends again, right? So 1 TB is like costing very less. So storage is not matter. If you lose the data, then let's assume that I have last 6 months data. I lose the last 6 months data. Will I get back it? So data is more important than your storage. So that's why I'm very much okay with the 3 copies. I'm very much okay with the 4 copies. Not at all problem, because I can go ahead and buy a hard disk easily. So you have a auto replication. The 7th one is, let's assume that my data is increased, my cluster is getting full, but actually it's not full, right? Because always we'll be checking the health, we'll be checking the reports and all. So when we feel that when it reaches to some threshold, will be there, it will be keep sending you messages. So when I feel my cluster is getting full, I can go ahead and put one more node in the live. I no need to stop. I can add 2 more nodes. I can just give a connection. I have a auto scale out. Understand, guys? Any doubts? Are you guys good to go, or are you guys stuck somewhere? Do we solve all these limitations? Srikanth? Oh,
Hello.
some network issue is there?
Ravi?
Yeah.
No, we couldn't hear your voice.
Okay. So which point you are not clear?
The last one, sixth
Okay.
one and 7th.
Okay. 6th one is automatic replication. Automatically it will copies 3 places. That you guys are clear, right?
Yeah.
Yes.
Devasis or Suman?
Yeah, clear.
Yeah.
The 7th point is
Yes.
auto scale out. Let's assume that my data is
we can
increased.
hear
Sorry?
Yeah.
My data is increased. So I no need to stop my cluster.
No.
I can add a machine directly. I can connect it. So I can automatically scale out. Clear, guys? Any doubts?
Yeah.
Any
It's
doubt?
fine now as of now.
It's going good, right? So this is a demonstration. I think it's taken so much of time. So I'll just show you a small PPT. Then we'll wind up today. It's already 8:40.
Yeah.
what time we started? Oh, 1.5 hours, more than 1.5 hour. Just give a few seconds of a few minutes of time and I'll wind it up. That's why always my demo, right? So I want to give a full-fledged demo, so I don't want to, here and there, I don't want to stop it. So that's why it'll take for me. So this is my PDF which I have prepared for a few guys. Let's see. Okay, I'll just quickly go through it. Okay, so big data, what is the big data we have discussed, and examples of the big data. Devasis, are you there? Okay, fine. No, if you miss something in the last part, right, you can view the video later point of time. So characteristics of big data we have seen, challenges associated with the big data we have seen, right? So challenge
Yeah.
associated means the time consumption, all those are the challenges. And the traditional approach, how it's proceed, we have seen. So big data, how much big it is, we have seen. If you say data changes, hello, tell me, Suman. Like while storing, while sending the packet itself, the first data node one itself is failed, how it will handle? It's a very good question. So we have separate classes for the write flow, read flow. Okay. So if I explain there you have failure scenarios, you have a successful scenario. So we will be discussing both. Okay. Let's see here.
Yep.
The big data, the changes in 80s, how much the data changes, how the data is grown, and you can see the different kind of data structure, semi-structure. And actually here also I have, it's only five V's I'm showing. It's actually 6 V's which I have explained you guys, and these are some notes about it. The different sources where you'll get the data, and the variety, what is the variety, velocity, value, these things we have discussed, and what are the challenges associated with it. This is the traditional approach, and what are the challenges we have seen: cost, time, parallelism, those things we have discussed. And so I want to show you only one thing. The conclusion is, so, learn the big data and earn the big salaries. That's the conclusion. And this is the history. So I have very nice history. I'll explain the history later point of time. No have to worry about it. Okay, here,
The difference.
go ahead.
Yeah.
So we have the features. Even I need to cover these features and all. I would like to cover these things, the features of Hadoop, and I'll be covering all these things. Okay, and I'll be tomorrow I'll be covering the features. Please join the class. Okay. And
Okay.
Hadoop ecosystem. What are the components? What is the HDFS?
In the
What
morning?
is the map address? Yes, in the morning 5:30. Okay. And yeah.
So Ravi, there was,
Yeah, Devasis, tell me.
we'll be able to catch from tomorrow's class, right? With these basics.
I'll make sure that you'll catch it.
Whatever
So
you explained today.
yeah. Yes. Yes.
So the very was asking about what is the difference between big data and Hadoop.
So I already, big data is it's a terminology for the huge amount of the data.
Yeah.
And whatever
Hadoop,
Hadoop you told, it's a Java-based
Hadoop is a framework. Hadoop, exactly. Hadoop is a framework where you can store the big data, where you can process the big data, huge amount of the data, ideally. Okay. So I'll be explaining you.
Okay, so tomorrow 5:30 you are going.
No. Tomorrow 5:30 we'll be seeing the features of the Hadoop, and we'll be I mean, see, actually for those guys we have done the installation part. Okay, so I would like to explain some of the configurations, why we have done this configuration, why we have done this configuration. So I'm going to explain some configuration from there tomorrow.